Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronic Engineering, Institute of Aeronautical Engineering. So in today's class, we are going to discuss some numerical problems based on the Z parameters. So the Z parameters are also called as the impedance parameters and also called as the open circuit parameters. So we have already discussed why these Z parameters are called as the open circuit parameters. Why? Because here also to understand that, let me take one example problem. So here in this problem, refer to the circuit shown in this below figure. So find the Z parameters of the circuit and also compute the current in the 4 amperes load if a 24 volt source is connected at the input port. Right. So in this problem, there are two sections. In the first section, we need to find the Z parameters, and in the second section, by connecting the 4 ohms resistor at the secondary side and the 24 volts voltage source to the primary side, then for that circuit we need to find the current flowing through this 4 ohms resistor. Right. So first let us go with the first section. So in the first section, we need to find the Z parameters. So in this, of course, as we know the Z parameters, there are here, let me just write Z11 and Z12. So Z21 and Z22. Right. So as we know, Z is equal to here V by I. Usually Z is equal to V by I. Right. So the same way here, Z11 is equal to here V1 by I1. And Z12 is equal to V1 by I2, and Z21 is equal to V2 by I1, and Z22 is equal to V2 by I2. Right. So as we know, these Z parameters or the impedance parameters are also called as the open circuit parameters. So why we are calling as the open circuit parameters, which means here, suppose if you want to find these Z11 and Z21, these two parameters. Right, as you can see here in the denominator, so I1 and I1 is there, which means here this we can find by making I2 is equal to 0, and this we can find by making I2 is equal to 0. So when I2 will become 0, when the secondary side is a open circuit. So which means if you want to find Z11 and Z21, so we have to make it the secondary side as the open circuit and connect a voltage source to the primary side so that we can find Z11 and Z21. Similarly, here Z12 and Z22. As you can see in the denominator, again here I2 is there, here I2 is there. So which means here we can find this one by making I1 is equal to 0, and this is also by making I1 is equal to 0. Which means to find Z12 and Z22, so we have to make the primary side as a open circuit and the secondary side we can connect again some voltage source V2, so that we can find the other two Z parameters, which are Z12 and Z22. So that's why these Z parameters are the impedance parameters are also called as the open circuit parameters. Right. Right. So first let us find here Z11 and Z21. So to find Z11 and Z21, as we already discussed, okay, so we are connecting the voltage source V1 to the input terminals and we are making the open circuit as the output terminals, right? So if you do this thing, then this circuit will become like this, because here, as you can see here, we have applied the open circuit at the secondary side and we have applied, we are connected the voltage source to the primary side, right? So by using this circuit, now we are going to find Z11 and Z21, right? So then how to find here? First, let us find here Z11. So to find Z11 here, of course, as you can see here, there are two loops are there. Okay. So first let me apply the KVL to the loop 1. So let us consider here it is loop 1 and here it is loop 2. Let us consider. So apply the KVL for the loop 1. So that if you apply the KVL for the loop 1, KVL for loop 1. So if you apply KVL for loop 1, so V1 V1 which is equal to, so here 12 volts is there, so 12 into I1 plus here 6 into I1. Because here I2 is equal to 0 because there is an open circuit, so I2 is equal to 0, so that's why we won't get 6 into I1 minus I2, but anyway I2 is equal to 0, so that's why 6 into I1. So then here V1 which is equal to 12 plus 6, 18 into I1, right? Then if you send this I1 to this side, so here V1 by I1 which is equal to 18, right? So we know already what is V1 by I1, which is equal to Z11. So here Z11 which is equal to 18 ohms. So this is how we can find one Z parameter. Similarly, to find the other Z parameter, which is Z21, right? Okay. So to find the Z21 here, now we are applying again the same KVL to loop 2 or the mesh 2, right? So then here what it is, of course, let me write here minus V2 plus here 3 into, of course, I2, it is 0, right? Then plus 6 into I1 which is equal to 0, right? Then if you simplify this, here you will get V2 is equal to 6 into I1. Then if you send this I1 to the left hand side, so V2 by I1 which is equal to 6 ohms. So V2 by I1 which is nothing but here it is Z21. Then here Z21 which is equal to 6 ohms. This is how we can find the Z11 and Z21 by making the secondary side as the open circuit and by connecting the voltage source V1 to the primary side, right? Then in the second case, now we are going to find the other two parameters which are Z22 and Z12. So to find Z22 and Z12, we know already what is Z22. Here it is V2 by I2 and here it is V1 by I2. So by making I1 is equal to 0. So how to make I1 is equal to 0? By applying an open circuit to the primary side, okay, and by just connect the voltage source V2 to the secondary side. So then here, the same way that we are going to do here, then the circuit will become like this. So the primary side here it is open circuit and the secondary side we are connected the voltage source V2. So now again do the same thing here, right? So just apply the KVL to this particular mesh, to the left side mesh, and this is, let us consider, right side mesh. So first apply the KVL to the left side mesh. Okay. So what it will be? Here V1 which is equal 12 into, because it is open circuit, so 12 into I1 actually, but I1 is 0, so 12 into 0 plus 6 into I2, right? Then here V1 is equal to 6 into I2, then send this I2 this side, so V1 by I2 which is equal to 6. So already we know what is V1 by I2, which is Z12, right? So here Z12 which is equal to V1 by I2. So by making I1 is equal to 0, which is equal to 6 ohms, right? Then now we need to find the second, the fourth Z parameter, which is Z22. So further just apply the mesh analysis to the right hand mesh. Okay, then it will be minus V2 plus, here this is 3 I2 and plus 6 I2 which is equal to 0, right? Then here V2 is equal to 6 plus 3, so 9 I2, then again send 9 this side, so V2 by I2 which is equal to 9, so which is Z22. So then here Z22 which is equal to V2 by I2, right? So by making again I1 is equal to 0, which is equal to 9 ohms. Now we have calculated Z11 and Z22. Okay. So in the previous case, we have already calculated the Z11 and Z21. Right. So now we got 4 equations. Right. So this is how we can find the the Z parameters for the simple T network, right? So now we can write this in the form of voltage equations, because before the Y parameters that we have discussed in the last class or in the previous class, so there the current equations in terms of voltage, and here the voltage equations in terms of current, right? So that's why here V1 is equal to here Z11 plus Z11 I1 Z11 I1 plus Z12 into I2, and similarly here V2 is equal to Z21 I1 plus Z22 I2. So these are the voltage equations in terms of current. So that is for the Z parameters, right? So then now the first section has been completed, so that we calculated the Z parameters for the given circuit, and now then we will go for the second section in the given problem. The second section is we have to compute the current, which means here by connecting here, this is the 4 ohms resistor, and here we need to connect the voltage source, which is 24 at an angle of 0 degrees. That I didn't mention, but actually the value is 24 at an angle of 0 degrees. So which means here the circuit will become like this. So for this circuit now we need to find what is the current flowing through the 4 ohms resistor. Of course there are many methods that you can follow to find the current flowing through this 4 ohms resistor. Okay, so either simply what is that the mesh analysis, or you just find the total current. After that you can apply the current division rule. In that way also we can apply. Okay, so there are many ways to find the current flowing through this 4 ohms resistor. But anyway, here already in the given problem that they have given, what is that V1? Okay, that they have given 24 at an angle of 0 degrees, because already we are having the equations. What are these equations? V1 is equal to, so here the Z11, what is the value of Z11 here? 18 and 6. Okay, so 18 and 6. So here, which means here 18 into I1. Okay, so this is Z11 and this is Z21, and similarly Z12 and Z22. So which are also we have calculated just now. So here Z12 is 6 and Z22 is 9. Okay, so Z12 is 6 and Z22 is 9. So by using these equations, here V1 equation, which is 18 into I1 plus Z11 and Z12, so 6 into I2, and similarly here V2 is equal to Z21, here it is 6 into I1 plus 9 into I2. So these are the two equations, but already we know that is V1 is equal to 24 at an angle of 0. Okay, then similarly here let me write V2. So V2 is equal to minus 4 into I2, right? V2 is equal to minus 4 into I2. Just to substitute these two values here, because here okay, so in the place of V1 just 24, so which means 18 into I1 plus 6 into I2, which is equal to 24 at an angle of 0 degrees. So let us consider this is equation number 1, right? Then similarly here V2, in place of V2 you just substitute minus 4I2, okay, which is equal to 6 I1 plus 9 I2, right? You just send this I2 to the right hand side, so that this equation will become 6 I1 plus 13 I2, which is equal to 0. This is equation number 2, right? Then by solving these two equations, by solving 1 and 2, then we can get the value of I1 and I2. Okay, so by solving these two equations, then I2 that you will get, I2 is equal to here minus 0.73 at an angle of 0 degrees amperes. So this is how we can find I2 value. So this is very simple. Even you don't need to apply the mesh analysis or nodal analysis, okay, the other network reduction techniques. They're just simply by using these two standard equations, then we can find the current flowing through the what is that, the 4 ohms resistor, which is I2 actually, exactly, right? So this is how we can find the value of the I2. Now coming to the second problem, right? So this is also a kind of T network, but here this particular circuit is consisting of the voltage dependent current source. right? So suppose if a network having the voltage dependent current source, then how we can find the Z parameters for the given circuit that we are going to discuss here, right? So here also the same way, first we need to find the Z11 and Z21 by making what is that, the output terminals as a open, and by connecting the voltage source V1 to the primary side. So for that, here the circuit will become like this, right? So by using this circuit, now we are going to find Z11 and Z21, right? So of course, let me consider this circuit again, right? So for this circuit, so here as we know already here, let me consider here the two loops. Okay, already here in the first loop, the current is already predefined, which is I1, and the right hand side loop, the current is defined as a I2. So that's why here in between the middle, let me consider the current flowing through that particular loop is I3, right? So here it is clearly showing that here I3 is equal to what is that, the beta into V1, right? I3 is equal to beta into V1. Then now we are going to apply the KVL to the loop 1, right? So apply KVL to loop 1. So then here if you apply the KVL to loop 1, let me write, so V1 is equal to R1 into I1 minus I3, because both currents are in opposite direction. So I1 minus I3, right? Then substitute I3 is equal to beta into V1, right? So let me write here V1 is equal to R1 into I1 minus, here I3 is beta into R1 into I1, and here I3 is equal to beta into V1 into R1, right? Then now send this, what is that? Yeah, right, beta into R1. So then here, if you take here is V1 and here is V1, just send this one to left hand side. So R1 into I1, which is equal to here V1 plus V1 into beta R1, right? So here let me take V1 as a common, so that 1 plus beta into R1, and this is R1 into I1, right? So as we know already, Z11 is equal to V1 by I1. So then here just send this one to this side and this one to this side. Then here V1 by I1, which is equal to R1 by 1 plus beta into R1. So now this is Z11. This is how we can find the value of the Z11, right? So now similarly we can find the value of the Z, what is that, 21. Okay, so to find the value of the Z21 here, now we are going to apply the KVL to the loop, which is having here V1 to R2, V1 to R2 to R3 to V2. Okay, so which is a kind of super mesh, right? So if you apply, then you will get here, of course here it is minus V1 and R2 here it is plus R2 into I3. Okay, so and again here R2 is in this way. Okay, the same as like in this I1 direction, but here I2 is opposite direction, so that's why here I'm keeping of course anyway, but I2 is equal to 0. Okay, so anyway here it is minus R3 into I2, okay, plus V2, which is equal to 0, right? So if you simplify this, then we will get, because here I2 is equal to 0, substitute this one, and again because here what we are going to find here, it is just remember, keep in mind that there is Z21 that we are going to find. Okay, so which means V2 by what is that, I1 that we are going to find. So which means we have to just eliminate all other parameters except V2 and I2. So that's why here I2 is equal to 0 anyway here, right? So that we can eliminate I2, and again I3 also we should eliminate, but I3 also we are having I3 is equal to, because from here I3 is equal to beta into V1. Then substitute all these values here. So here minus V1 plus R2 into here I3 is beta into V1, minus is 0 because R3 into I2 0. Okay, so plus plus V2 equal to 0, right? Then from this equation here we can find the V2 value. So here V2 is equal to here if you take V1 again as a common, so 1 plus beta into R2, right? So we know from this, because here we need to eliminate the V2 also. Okay, so we need to eliminate the V2 also. So then, yeah, not V2, we need to eliminate V1. Okay, and we should get I1. So that's why what we can do here. So from this equation here, we know that V1 is equal to I1 into, okay, so R1 by 1 plus beta into R1, right? Then substitute this value, okay, from here. Then this equation will become here V2 is equal to I1 into R1 into 1 plus beta into R2 by 1 plus beta into R1, right? So then send this I1 to this side, so that V2 by I1, which is equal to R1 into 1 plus beta into R2 by 1 plus beta into R1. This is how we can find the what is V2 by I1, which is Z21. So only one thing that we should keep in mind when we are calculating the Z parameters. So here the thing is we need to find the Z21. Okay, Z21 means V2 by I2. So we should keep only V2 and I2. The all other parameters we should eliminate, right? So that's how here, because this is the basic equation. In this basic equation, so I2 and I3 that I have eliminated by substituting these two values. But anyway, again V1 is there, so I should eliminate V1. But here there is no I1, but we know the V1 equation in terms of I1. So from this equation we can substitute here, so that we will get V2 by I1, which is equal to R1 into 1 plus beta R2 by 1 plus beta R1, which is Z21. So this is how we can find the two parameters. In the second case again, to find Z12 and Z22, then now the same way, okay, so we should apply the open circuit to the primary side, and we should connect the voltage source V2 to the secondary side, right? So here, of course, the same way here also, okay. So first, what is that? Let me apply R, because here we need to apply the super mesh analysis, because we can't apply the mesh analysis to the this I2 loop or I3 loop, because in between there is a current source. So that's why we should go for the mesh analysis. Okay. So then how we can go for the mesh analysis? First we should write, or we should apply the KCL at this particular point. Okay. Then after that, by eliminating this, we have to consider this pole as a one loop. Then from that we will get the another equation. So by using those two equations, we can find the other two parameters, which are Z12 and Z22, right? So first let me write here. This is, if you write here, this is, okay. So this is entering current, sorry, I3 is the leaving current and I2 is the entering current. Okay. So that's why here I2 minus I3, which is equal to beta into V1, right? So then here, and we know already what is that, V1 is equal to I3 into R1, right? So V1 is equal to I3 into R1, that also we know, right? So by using these two equations, then here I2 minus I3, sorry, I2 minus I3, which is equal beta into, because actually here what we are going to find, okay, that I will let you know. So here beta into, in the place of V1 we can substitute I3 into R1, right? So then if you find I2 from this, okay, so I3, okay, I3, if you take it as a common I3, then here 1 plus beta into R1. So let me consider this is equation number 1 in this particular case, right? Then another equation, we need to consider the super mesh. Okay, so how to consider the super mesh? Here it is, by making here R3, R2, okay, and R1, and again here it is V2, right? So which means here this is the super mesh. Fine. So then, of course, the currents are different anyway. In the first case, the current is I2. In the second case, the current is I3. So if you write here the mesh equation, here first let me start with here R1, R2, R3. Okay, let me start with R3. So R3 into I2 plus when going to the R, then again here, yeah, R2 plus R1, right? R2 plus R1 into I3, because this I3 is flowing in is R2 and as well as R1. So into I3 minus V2 is equal to 0, or in another word, simply we can make it is equal to V2, right? So here we should keep in mind, like we are going to find here the Z12 which is equal to V1 by I2, okay, and Z22 which is equal to V2 by I2. So which means whatever the equations that we are writing, so from those equations, or by using those equations, we have to make either V1 by I2 or V2 by I2, so that we can get Z12 or Z22, right? So then if you simplify this, you will get here R3 into I2 plus here, as you can see, this I3 we should eliminate from here, because so that V2 by I2 that we can find. So if you want to eliminate this I3, so from this equation you can see I3 is equal to I2 into 1 plus beta into R1. So wherever I3 is there, you can substitute this here. Then here in place of I3 we can substitute I2 into, of course here already R1 plus R2 is there, okay, R1 plus R2 is there, and here 1 plus beta R1 which is equal to V2, right? Then take I2 as a common here, so that I2, so that here you will get R3 plus R1 plus R2 by 1 plus beta into R1 which is equal to V2. So then send this one to the right hand side, so that here you will get V2 by I2 which is equal to R3 plus R1 plus R2 by 1 plus beta into R1. So which is equal to Z22. So this is how we can find the Z22. Now we need to find Z1. Z12. Right. So to find Z12 again here, what I am going to do is just apply the KCL at this particular node. Okay. So if you apply the KCL at that particular node, again the same like in the previous case. Okay. So beta into V1 plus I3 which is equal to I2. Right. So anyway, beta into V1 we can write as usually beta into, because here it is V1 by I2. So V1 is there, but we need to eliminate I3. So beta into V1 plus here in place of I3, okay, where is I3? Here it is, here I3. So in the place of I3, we can write it as a V1 by R1. Okay, so which is equal to I2. Then if you simplify this, finally you will get here Z12 which is equal to V1 by I2, that you will get R1 by 1 plus beta into R1. So this is how we can find the value of Z12, right? So here the only difference is, of course, in the previous problem and this problem. So previously it was a simple T network. Of course, here also it is a simple T network, but the extra thing is here we are also having a dependent current source. I mean that is voltage dependent current source, right? So in that case, instead of applying, because in the previous case what we have done, just we have applied a simple mesh analysis to find the Z parameters in the two cases. So here also we have done the same thing, but here by including this current source, okay, so it will become the super mesh circuit. So that's why here we have applied the super mesh analysis. Okay, other than that, I mean both the problems are the same. So now this third problem is in the reverse way. Okay, so I mean, which means here already they have given the Z parameters. Okay, so from that Z parameters we have to construct the circuit, because in the previous cases from the circuit we have calculated the Z parameters. So now from the Z parameters we need to construct a circuit, right? So first what we can do is, first we should compare this Z parameters matrix with the standard Z parameters matrix. So which means Z11, Z12 and Z21 and Z22. So which means here in the place of Z11 here it is 12, and in the place of Z12 here it is 4, and in the place of Z21 here it is again 4, and in the place of Z22 here it is 8, right? So let us consider here it is a T network. Okay, so for this T network now we are going to find R1, R2 and R3 values, right, from the Z11, Z12, Z21 and Z22 values, because before with the help of R1, R2, R3 values we have calculated the values of Z11, Z12, Z21 and Z22. So now the vice versa. So by by considering the Z parameters we are going to find we are going to construct the network with the resistor values R1, R2 and R3, right? So for that here the same way again. Okay, so which means now because what are the equations to find, I mean from the Z parameters? Okay, so that is here the equation is V1 is equal to Z11 I1 plus Z12 into I2. Similarly here V2 is equal to Z21 I1 plus here Z22 I2, right? So now we have to develop the equations like this standard equation, so that we can find what is R1, R2 and R3 values. So here let us apply the KVL to the loop 1. Okay, so if you apply the KVL to the loop 1, then what you will get here, V1 which is equal to R1 into I1 plus R3 into I1 plus I2, right? So just to make it this equation into the standard form, so that here it is of course here R1 into R1 plus R3 into I1 plus R3 into I2, right? So which means here if you compare the equation number 1, let us consider this 2 and this is 3. If you compare 1 and 3, okay, so what you will get here, Z, not Z, okay, here R1 plus R3 which is equal to, in the place of this here Z11 is there, Z11 value is 12, and R3, okay, so in the place of R3 here it is 4 is there, then 4. So if you substitute R3 here, then 12 minus 4 here it is 8. So here R1 is equal to 8 ohms and R3 is equal to 4 ohms, right? So here R1 and R3 values that we have got. Then now what is the other value that we need to find? That is R2 value. Then to find the R2 value, okay, again just write the V2 equation. Okay, so just write the V2 equation. So for the V2 here again the same way, V2 which is equal to R2 I2 plus R3 into I1 plus I2, right? Then the same way, so here R3 into I1 plus here R2 plus R3 into I2, so which is V2. So already V2 just now we have calculated. Okay, so if you compare this is, let us consider equation number 4, just compare equation number 2 and 4, okay, so that you will get here R3 value, right? So that R3 is equal to 4 ohms, right? And then R2 plus R3 which is equal to 8 ohms. Then substitute here the 4 ohms, then so that you will get R2 value also which is 4 ohms, right? So now we have calculated what is that R1 R1 is equal to 8 ohms. So which means here R1 is equal to 8 ohms and R2 is equal to 4 ohms and R3 is equal to 4 ohms. So now this is the circuit, right? So which means from what is that? From the matrix to the circuit, right? So this is how we can calculate from one point to another point, right? I mean either from the circuit to the impedance matrix. Okay, the impedance matrix is considering the impedance parameters which are Z parameters, right? And vice versa, from the impedance matrix we can also find the circuit, okay, and the values of the elements present in the circuit, right? So now we will discuss another problem. So this problem is also same like in the previous case, okay, because I'm not going to solve this problem because this is similar like in the previous problem that we have considered. So the only thing is this source was here and here the source was here, okay, just the current source, here also the voltage dependent current source, okay. So then how we can find, because another case here you are here they have given the values also, okay. So even you don't need to worry about R1, R2, R3, here directly they have given the values of the resistors in this circuit. So how to find this one? Okay, so let me just go through this one. So first anyway, to find the values of Z11 and Z21, so we are making the secondary side as a open circuit and we are connecting the primary side as a V1 voltage source, right? So this is how we can connect. So by connecting this again, now we can find the value of here. What are the values? Z11 and Z21 values that we can find. So how to find? Again the same way, right? Because here you can see again by this current source, okay, is in between the two loops. So that's why in this case also we need to apply the super mesh analysis, right? So how to apply the super mesh analysis? First of all we should find this one, okay, we should write this one. So which is what is that? I1, okay. So this is entering and this I3 is leaving. So I1 is equal to alpha into V2, okay, plus I3. Okay, I3 is also leaving, this is also leaving, and I1 is entering. So this is one equation. And the second equation is with the loop. What is that loop? Here it is, the loop is V1 with 4 ohms resistor and with 2 ohms resistor and with 3 ohms resistor, right? So in this case, what will be the equation here? So V1 is equal to here 4 into I1 plus 2 plus 3, 5 again. So 5 into I3 directly. So 5 into I3, right? So by solving these two equations, we can find the two values, which is Z11 and Z21, right? Then in the second case, to find Z22 and Z12, now in this case we are making the primary side as an open circuit and the secondary side we are connecting the voltage source V2. Then here also the same way, okay, just apply the first the mesh analysis, okay, for these two loops, okay. Then after that you just apply the super mesh by considering all these, okay. Then you can find the value of Z22 and Z12. So this is all about the various numerical problems based on the Z parameters, right? So if you go through these various problems, then you can apply the same analysis to any network so that you are able to find the Z parameters. So the only thing that you need to remember, that we should remember here it is, so what is Z11 and what is Z12 and what is Z21 and what is Z22, right? So because as you can see here, the second what is that numbers, okay. So here 1 and 1, which means you must make I1 I2 equal to 0, and here 2 and 2, which means you must make I1 is equal to 0. That is one thing. And the second thing is here V11, here it is V1 by I1, and here it is Z21, here it is nothing but V2 by I1. So whatever the equations that you are writing, so you have to make sure that that equation, okay, from that equation you have to eliminate all other elements except that V2 and I1. Suppose if you want to find Z21. And if you want to find Z1, then you have to make sure that, okay, so other than V1 and I1, all other parameters should be eliminated. So by making or by following this process to make the V1 by I1, so that you will get the all the parameters. So if you remember these key points, then we can apply this procedure to any given network, so that we can find the Z parameters, right? So the remaining parameters we will discuss in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.